All right, so we did everybody's favorite task and reversed our chuck jaws, got that loaded in there, zeroed up to about 1,000. Threw the steady rest in where you see, just eyeballed the steady rest position with the spindle. There's all sorts of other better ways we could have done it. And there's also a way of presetting your steady rest that I'll get into in a different video. But this one's going to be more about the 2 dial indicators to get this zeroed out and without too much consternation. So we've got a terrible spirit level on one of our chuck jaws. We've got our Joe Piesinski style tool center height gauge. Put a mark there, roll the shaft over 90 degrees. Doesn't have to be perfect, but close is better. Put a second mark so we have a mark on the top and 90 degrees from that. So now we're going to lay out how far we're running our dial indicator up and down the length of the shaft. So we've got the tape measure set against as near as we can to the chuck jaws or chuck face, wherever the pivot point there is, but that's close enough. It always is nice to get this into a whole number multiplier. In this case, we could easily go 30 to 40 inches, so that's a distance of 10 inches, with the end result being 4 times that 10 inches from the chuck. So that's a multiplier of 4. That would be a very good layout to use, but you can use random layouts. You just have to decide what your interval is going to be, or your multiplier. So we're going to take 28 inches and then divide that by 4, which would be 7, and then times 5 is 35. So that gives us a multiplier of 5. So we're running our dial indicator over a 7-inch length, and whatever the reading is, when we move from there to there, when we're correcting, we multiply that amount by our multiplier. In this case, it's 5. Hopefully that makes sense. Probably didn't, but we'll do it again someday. So I've decided to move down a little ways here, and it just demonstrates a different way of laying out. You can start with your final distance, which in this case is going to be 45 inches. So we're going to divide 45 by 5 and then multiply that by 4, and that gets us 36. So we're going to be moving from 36 to 45, which is going to be our ending distance is 5 times the interval that we're moving. We'll see why we need to know that in a minute. All right, so here we got a couple dial indicators set up pointing at our lines. Close is good enough because they'll move around a little bit. After you get it somewhat roughly zeroed, you want to then adjust their position so that they at your final sweep, you've got that pointer right on the reference edge of your Sharpie line, which in this case would be the near side and the lower side. They don't have to be mounted on the carriage, but it is the most accurate. If it was on a sled for the roughing in, that's just fine. And now we run the carriage down that 9 inches, which is going to stop 45 inches from the chuck, which means that this dimension here is 5 times this dimension here. So whatever reading we've got in the dial indicator, we have to then move 5 times that amount to correct it. So whichever distance this needle has moved, there's 5 times 20 would be 80 thousandths. So we have to increase. We're going to move that dial that same way, so there's 80 thousandths. And when we correct here, we want this needle to sweep clockwise. You got to remember that. If you're going a long way, you can get messed up. So here we've got about 18, and because it's been a long day, we're going to multiply that by 5 on the calculator, which is 90, which everybody already knew that. And so we're going to swing this over to 90 thousandths. If the needle has moved this way, we need to keep moving the dial that way, so we swing to 90 thousandths. But In this case, this dial has to go anti-clockwise, counterclockwise in some countries, and this dial has to go clockwise. So then we manipulate the screws on the steady rest to accomplish that. Generally, you can just back the top roller off altogether to give you some wiggle room. It depends how heavy the part is. You do have to watch that if you're pushing it around, it does need to be sort of helped back down once in a while, so I'll do that. So there you are, we've got those zeroed. It takes a little bit of getting used to the whole sort of running the steady rest, so to speak. It's if you turn this knob this way and the far knob that way, you'll be moving the part across. If you move them the same amount, the part will not go up and down, it'll just go side to side. So a lot of times it's easier to sort of chase that vertical dimension to 0 and then get the horizontal dimension where you want it, but it's totally up to you. Then run the carriage back to the starting point, and you want to, when you're taking your readings, run the carriage back and then advance it slightly, because most carriages will rock just a little bit. So when you start this, you want to overshoot it, come back to 0, set the dial indicators, run to the end, take the reading, and likewise run back this way, overshoot it, and then advance the carriage a little bit back to the line, and then observe your dials, reset to 0, run to the end, take the reading. All right, so now we're down at our starting point, and we've got both dial indicators zeroed, and the moment of truth, we run down that 9-inch length, and we take a reading, and we're pretty darn good here, and we're a ways out there. Now, it's really hard to get this bang on right off the hop if this has been crooked a little bit. As the dial indicators are moving up and down the bar, they will no longer be on that crest of the bar, so to speak. They'll be drooping off one side or the other, and you're getting a false reading. So you got to do it a couple of don't expect perfection. Just keep running back and forth, and each time you get it closer, that error becomes less, and in no time flat you'll have it there. So the same rules apply. If this is out 1 thou, multiply it by 5, turn the dial that same sort of direction to 5. If this is out 6 and change, we're going to move that to 30. In this case, it's going to read 70 because you're moving that same direction. So it's now we adjust the steady rest again until those both point at 0, and rinse and repeat. So we got those dial indicators set at 0 at the far end. We'll run back to this end, overshoot it, come back on it, 0 up again, and then run to the end to prove your work. So this is we've adjusted the steady rest twice, and there is the result. So we're within about 1/4 of a thou on the top, and probably the same there. So we're within 1/4 of a thousandth error over that 9 inches. So we could tweak it one more time, but the class of work that we're doing, it doesn't matter. Remember what class of work you are engaged in, and if you need to, take the time to make it perfect. If you don't need to, get on with the next step. It doesn't hurt to double check that it's still true at the chuck end, and it doesn't hurt to roll the bar over. If it is bent, you're going to want to do this sort of averaging that error. But of course, you're not likely to be doing precision work on a bent bar, so this will get you close, and then you can turn it true and then take a second stab at it to get it zeroed up for your final cuts. What you're doing is you're getting this bar parallel to the bed in 2 axes in this area. So whatever area you're going to work in, that's where you should be doing your indicating. That way, if your bedway is twisted, it'll account for it. And this solves that issue of setting up a steady rest, like putting a chunk of material in the chuck here and zeroing your steady rest to it. You move it down the bed, it may or may not be the right location anymore to get your material parallel in the bedway. This lathe here is really good. It's a good stout lathe, and it's sitting in a good place on the floor. But this the long lathe here that's doing epoxy detail right now, it has a bed extension on it, and the extension over here is out by you know, 3/4 of an inch or something. So you cannot get your material zeroed up to that usable section of bedway by just poking your tailstock center in the end of the material. And sometimes you can't reach the end of your material. So this solves that issue. And now we're going to take this, we're just going to part off the material to its final length, and that'll get rid of this nut the welder put on for lifting purposes, and then we can center drill, and that center drill will be exactly or nearly to exact enough in the center of that shaft so that everything we do after that will be zeroed up off that center drill hole. So here we got the 0.5 resolution indicator back in there, and it's always nice to see that. Rather satisfying. Always makes you wonder if the darn thing's actually working. That'll work.